Alrighty guys, so today we're going to be looking at Unit 6, Notes number 2. And we are going to be factoring a polynomial when the a value is 1. So remember, a quadratic function is always written in standard form, just like we did in Unit 5. And it always looks like ax squared plus bx plus c. And remember, we did the opposite of b over 2a, and we looked at those to find our vertex of our parabola. So that's basically where I'm getting whenever I say the a value is 1. This first number will always be a 1. Alrighty, and we're going to be factoring those today. So what is the goal of factoring a polynomial? Okay, we are doing the inverse of multiplying. So if given a quadratic function like the following, to factor, so when we're looking at this, to factor we have a few special methods to use. So yesterday we talked about finding the greatest common factor. Well, this one does not have a greatest common factor because see, this 9 doesn't have an x, and the first number is a 1, just like we talked about, the a value is a 1. So there's no greatest common factor. So since there's not a greatest common factor, we're going to use this next method to try and factor it and break it apart. So factoring when a value equals 1. So looking at this, the first step says check for a greatest common factor, just like we did yesterday. If I look at this quadratic, my coefficients are 3, 3, and 18. So the greatest common factor of 3, 3, and 18 is in fact 3. So we're going to put that out front, and then we're going to put our leftovers back in the parentheses, just like we did yesterday. So 3 divided by 3 gives me 1, x squared. Negative 3 divided by 3 gives me negative 3. Oh, not negative 3. Wow, I can't even divide. Negative 3 divided by 3 gives me negative 1, x. And negative 18 divided by 3 gives me negative 6. So we've taken out the greatest common factor. So now our goal is to break it up into pieces. So we're going to set up some parentheses. The 3 just hangs out up front. And then we're going to set up 2 sets of parentheses. Okay, so see how I got those parentheses over here? That's your little reminder. Now this x squared, remember, whenever we have x squared, that really just means x times x. So we're going to break apart the x squared and we're going to put the x's up front. So now we get to think about those magic numbers that we talked about yesterday. What two numbers add to the b value but multiply to the c value? So I want to know what two numbers are going to add to the b value, so the number in the middle. So what two numbers add to negative 1, but when I multiply them, I get a negative 6. So when I think about numbers that multiply to give me 6, I think of 1 times 6 and 2 times 3. Well, there's no way 1 and 6 can give me negative 1. But whenever I think about 2 and 3, if I do 2 minus 3, that does get me to negative 1. So I know my magic numbers are going to be 2 and negative 3. Okay, because those two numbers multiply to give me the negative 6. And whenever I add them or subtract them, because I can think of this as being a negative, 2 plus a negative 3 or 2 minus 3 give me the negative 1. So these are going to be my magic numbers. So now we're going to set up our parentheses to match. So the 3 is still just hanging out front. So 3, and then x plus 2, and then x minus 3. And that right there is how we are going to be factoring. We're breaking this apart into pieces. Now remember, this looks like what you guys did on the very first day, notes number 0, where then, after doing this, we would set this equal to 0 and solve it. So you'd set all your little pieces equal to 0 to solve. Now, how do we check our work? We distribute to check our work. And we will practice doing that down here. Alrighty, we're going to factor the next one. The next one we got is x squared minus an x minus 20. So step number 1, if we check our notes, says check for a GCF. Okay, Well, if I look at this, there's not an x here with the 20, so they don't have an x in common. And my very first number is a 1. Therefore, there is no greatest common factor. Sweet. I get to skip that step. The next step is to set up your parentheses. I like to leave myself some room because I know I'm going to write up here. And then I break apart the x squared so the x's go up front. Now I have to come up with my magic numbers, so I need to think what's going to add to give me -1 and multiply to give me -20. So what adds to give me -1, but multiplies to give me a -20. So I have to think about what numbers multiply to give me 20. So I'm going to make my little list. If you get comfortable and you don't need the list, that's totally fine. Okay, but I like to have my list. So I've got 1 times 20, because we're figuring out what multiplies to give me 20. 2 and 10. 3 does not go into 20, but 4 times 5 does. So there's no way 1 and 20 can give me -1, so that's out. There's no way 2 and 10 can give me -1, so that's out. 4 and 5, though, is another matter. Okay, so because if I think about it, if I'm getting to -1, I can do 4 minus 5 gets me to -1. Okay, so I can rewrite this as 4 and -5 get me to -1. 4 and -5. So that's going to be my magic number. So I'll have x plus 4 and x minus 5. And I have factored it. So now we need to check our work, because that's the cool thing about factoring is we can check our work. So we're going to come over here and check our work. Alrighty, so our factors were x plus 4 and x minus 5. So to check our work, we're going to distribute. That's where we draw on all of our arches. So x times x gives me x squared. That's where that x squared comes from. X times -5 gives me -5x. Now we're going to distribute the 4. So 4 times x gives me plus 4x. And 4 times -5 gives me -20. From here, we have to combine our like terms. So the x squared just hangs out up front. -5 plus 4 gives me -1x. And I bring down the -20. And if I look, this right here is exactly what we started with. So that's how you can check your work, is to make sure if you multiply them together, you'll get back right where you started. Alrighty. Moving on to number 3. Or not number 3, wow. Number 2, but it has a 3 up front. So we've got 3x cubed plus 9x squared plus 6x. We start by finding our greatest common factor. So I think, what's the GCF of 3, 9, and 6? Well, that's a 3, so we put the 3 out front. And if we look at this, they all have an x in common. So that means my GCF is going to be 3x. So that's going to hang out up front. And then I'm going to put my leftovers back in the parentheses. So 3 divided by 3 gives me 1. I took an x away from x cubed, so now all I have left is x squared. 9 divided by 3 gives me plus 3. I took an x away from x squared, so that gives me an x. And 6 divided by 3 gives me plus 2, and I took that x away. So from here, I move on to step number 2, which if we look up here, if you look on the other side of your notes, we're going to be setting up our parentheses and then finding our magic numbers. So this 3x, I'm going to leave some room because I like to put my magic numbers in the middle. So the 3x just hangs out up front, goes straight down. I'm going to set up my parentheses. The x squared gets split apart and becomes x and x. And now I need to think what's going to add to give me 3, but when I multiply them, I get a 2. So remember, we always start by making a list of what multiplies to give me 2. Well, the only numbers that multiply to give me 2 are 1 times 2. And lucky for us, 1 plus 2 gives me 3. So my magic numbers are 1 and 2. So I'm going to just bring those down. So I have x plus 1 and x plus 2. It does not matter what order you write them in. If you flip-flop them and put 2 here and a 1, if you put 2 here and 1 here, that's totally fine. Alrighty. Now we're going to check our work for example 2. Okay, so I'm going to rewrite this just so it's a little bit easier for us to read. So I had 3x, x plus 1, x plus 2. Okay, I just rewrote that down here. And we start by distributing. So much distributing. So we're going to distribute the 3x. 3x times x gives me 3x squared. And 3x times 1 gives me plus 3x. And I just bring down my second set of parentheses. And now we get to distribute everything together. So 3x squared times x gives me 3x cubed, which is a good sign because remember we started with 3x cubed up here. 3x times 2 gives me plus 6x squared. And now we distribute the 3x. So 3x times x gives me plus 3x squared. And then 3x times 2 gives me plus 6x. We're going to combine the like terms in the middle. And we'll get 3x squared. 6 plus 3 gives me plus, oh, not squared. Jeez. Whoops. Oh my goodness. Okay. So 3x cubed. 6 plus 3 gives me plus 9x squared. And then I just bring down the plus 6x. So then if I look, that does take me right back to where we started. Okay, that's how you know you did everything perfectly because it gets you right back to where you started. Alrighty, we're going to skip example 3. You're welcome, you can scribble it out, get excited, but we are still going to do the next ones. So looking at number 4, it says solve the following quadratic functions by factoring. That means we are going to set it equal to 0 and figure out where it hit the x-axis. So just like what you did in notes number 0, we're going to set it equal to 0 and talk about where it hit the x-axis. So if I look at example number 4, I have 2x squared minus 8x plus 6. If I'm factoring this, the very first thing I need to look for is the greatest common factor. So I need to think what numbers go, or what is the greatest common factor of 2, 8, and 6. Well, if I think about that, that's going to be 2. So the 2 gets to go up front. And I'm going to put my leftovers back on the inside. So 2 divided by 2 gives me 1x squared. Negative 8 divided by 2 gives me negative 4x. And 6 divided by 2 gives me plus 3. Now from here, I got to find my magic numbers. So I'm going to set up my parentheses, but I'm going to leave room. So the 2 just gets to hang out front. And I put my x's in the front because I split apart the x squared, and that's where my x's come from. And now I get to think about my magic numbers. So what adds to give me a negative 4, but multiplies to give me a positive 3. Well, I need to make my list, but the only numbers that multiply to give me 3 are 1 times 3. So how can 1 and 3 give me negative 4? Well, if you're sitting there pondering that, I'm going to help you out. If I make both of them negative, so negative 1 minus 3, or negative 1 plus negative 3 gives me negative 4. But when I multiply them, 2 negatives make that a positive 3. So my magic numbers are negative 1 and negative 3. So I'll have x minus 1, x minus 3. Now, this is factored, but I didn't just ask for you to factor it. I asked for you to now solve it. So we got to set it equal to 0. Okay, so we're going to set all of our pieces equal to 0. So I'll have 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. This is what you did in notes number 0. So this is why we're factoring, is so we can set it equal to 0 and figure out where it hits the x-axis. Well, we know that if I look at the first little one, 2 does not, in fact, equal 0. So that does not help us out. That does not tell us where it hits the x-axis. So we can cross that one out because that doesn't actually help us at all. Now this next one I've got is x minus 1 equals 0. So I'm going to solve for x. To get rid of the minus 1, I'm going to add 1 over. That'll give me x is equal to 1 because those canceled. And 0 plus 1 gives me 1. On this one, I'm going to add the 3 over. Those will cancel, and I'll have x is equal to 3. So I know that my solutions are going to be 1 and 3. Whoops, not a parentheses. Do not make that mistake and write a parentheses because this is a solution set. So if I were to draw a little sketch, I know it'd hit the x-axis at 1 and 3. So 1 and 3. I'm just estimating, right? That's why it's a sketch, not an actual graph. Our a value is positive, so I know it opens up. So it's going to look like this. And you can also put it into the calculator to check your work, and your graph will look kind of like that. Not perfect, obviously, but kind of like that. Alrighty. Moving on to let's move on to number 6. We'll do more of these solving ones in the next few days, but we're going to move on to number 6. It says, what two binomials multiplied together give the polynomial x squared plus x minus 20? This is really just a fancy way of asking you to factor it and set it up into your two binomials. That's really what we're asking here. So, what two binomials multiplied together give the polynomial? We want to first factor this, so we're going to set up our parentheses. The x squared gets broken apart. There's not a GCF because this 20 doesn't have an x with it, and our first number is a 1. So there's no greatest common factor, so that's nice. We get to skip that step. And now we get to come up with our magic numbers. So what adds to give me a 1, but multiplies to give me a negative 20? So we're going to set up our list. So I've got 1 and 20, 2 and 10, 3 doesn't go into 20, but 4 does, so 4 and 5. So I need to think, how can I make one of these sets of numbers give me a 1? Well, 1 and 20 sure don't work. 2 and 10 sure don't work, but 4 and 5, though, those are 1 apart, so I can make those work. If I think about it, 5 minus 4 gives me 1. So we're going to have 5 and negative 4. Now, if you wrote it as negative 4 and 5, that's totally okay. So my magic numbers were 5 and negative 4, so I have x plus 5, and then x minus 4. Now, this problem doesn't ask you to, but if it had said solve it, then that's whenever you would set it equal to 0 and solve. Alrighty, we're going to go ahead and stop there, okay? So that you can move on to your homework. If you have any questions, make sure you're asking the teacher you're with, okay? Or you are welcome to email me at any point. All right, but you can move on to your homework.